channel, and today I'm going to be talking about implicit differentiation. So what is implicit differentiation? Well, here's an example to illustrate what implicit differentiation is. So say we have x squared plus y squared is equal to 16, and we want to take the derivative of both sides. Well, the derivative of the right-hand side, which is the derivative of 16 with respect to x, that's just going to become 0. On the left-hand side, the derivative with respect to x of x squared plus y squared, well, x squared is going to become 2x. But what is y squared going to become? Well, since this is not partial differentiation, what method do we have to take the derivative with respect to x of y squared? Well, that method is implicit differentiation. So implicit differentiation is just essentially an applied chain rule method. So let's actually discuss the mathematical approach behind the applied chain rule method or implicit differentiation. So we're stating that y is equal to f of x. Well, then h of y must equal to h of f of x. But then the derivative of h of f of x, well, that's just essentially h prime of f of x, and then we're going to multiply by f prime of x. This is from the chain rule. Well, if h prime of f of x multiplied by f prime of x is going to be the derivative of h of f of x, and f of x is equal to y, then f prime of x must be dy over dx. And if f of x is just y, this is just h prime of y times dy over dx. So this is essentially just the derivative of y. So this is just the derivative of the function, which is in terms of y, multiplied by dy over dx. Well, the derivative of the function in terms of y, which is y squared in this case, the derivative is 2y, multiplied by dy over dx. So we write dy over dx. And that essentially is what implicit differentiation is. We just take the regular derivative of the other variable, which is y in this case, but specifically in this case it's y squared, and then we multiply by dy over dx once we take the derivative of that. So this is just technically the formula for the distinct variable or the other variable in terms of y, which we have over here. So now that we have discussed this, we have two example problems over here which we're going to be doing. And there's also another short trick which we're going to be talking about today. This trick involves partial derivatives. So if you haven't learned about partial derivatives, please visit my other videos. Okay, so we're going to have the first problem, which is 9y squared plus x squared y minus 4x cubed plus 7xy is equal to 7. Well, if we use this method, we're going to solve it quicker. But let's do the regular method first and then use this method. Well, if we write this down over here, 9y squared plus x squared y minus 4x cubed plus 7xy is equal to 7. And notice that on the right-hand side of these equations, 7, 19, well, it's in 7 and 19, when we take the derivative of them, they become 0. So we really don't care about the right-hand side. So on the left-hand side is where we have to do the mathematical computation. So 9y squared, if we take the derivative with respect to x and use implicit differentiation, this is going to become 0. With the 7, it's going to become 0 once we take the derivative with respect to x. But on the left-hand side, this is going to become 18y dy dx plus, now we have to use the product rule, x squared and the derivative y is dy dx. So we have x squared dy over dx plus 2xy and minus 12x squared plus 7x dy over dx plus 7y. So this essentially is just going to be the whole equation, which we have to do some algebraic computation now to solve. So let's just check it. 2 times 10 is 18, 18y, and since this is in the terms of y, we have to multiply by dy over dx plus x squared dy over dx, since the derivative of y is going to be 1, and 1 times dy over dx is just dy over dx, plus the derivative of x squared is 2x, so we're just going to have 2xy, and then the derivative of minus 4x cubed is just minus 12x squared, and then plus 7x, the derivative of y is dy over dx, plus 7y, since the derivative of 7x is just going to be 7. So we have this whole equation over here, which we have to solve and do some algebraic computation. So normally, how would we solve this? Well, we would take all the terms that do not have a dy over dx, which are these terms, and just move it to the other side. So this will become 12x squared, so this will become positive 12x squared. This will become negative 2xy. This will become negative 7y. Now, this is equal to all of the other terms on the left-hand side. So we move the sum of the terms that do not involve dy over dx to the right-hand side, and we take the terms on the left-hand side, and we can notice that we can factor out a dy over dx. If we do, we'll get dy over dx factored out of x squared plus 18y plus 7x. And now we can just divide by this, x squared plus 18y plus 7x, x squared plus 18y plus 7x, and essentially we're done. So this is going to be our answer, but let's just check it. So if we move this, so this will become positive 12x squared, this will become negative 2xy, this will become negative 7y, so the numerator is correct. On the denominator, we have x squared plus 18y plus 7x. Well, x squared, that's just going to, well, if we factor out the dy over dx, this is going to become x squared since it's matched with dy over dx, 18y, and 7x. So this, the denominator, is also right. But there's another way which we can check it and even solve it. This is this method, but it involves partial derivatives. So that's one thing we have to caution if you do not know about partial derivatives. So let's just write the answer down and then see if we can use this method to get the same answer. Okay, so now let's use this method. So this method is just saying we have minus 1 multiplied by the partial derivative of this equation with respect to x over the partial derivative with respect to y. So if we take the partial derivative with respect to x and multiply it by minus 1, well, the partial derivative with respect to x is, this becomes 0, this becomes 2xy, this becomes minus 12x squared, and this becomes essentially this becomes 7y, so plus 7y. Well, if we multiply by a negative sign, this will become a negative 2xy plus 12x squared minus 7y, which we can rearrange to get 12x squared plus 2xy plus 7y. Minus actually for these, so these are minuses. So we get this over the numerator. Since these are minuses, these become minuses, and this is just a plus, so it becomes a plus over there. Now we have the partial derivative with respect to y. Well, this becomes 18y, this becomes x squared, this becomes 0, and this becomes plus 7x, which we can simplify into 12x squared minus 2xy minus 7y over x squared plus 18y plus 7x. And if we look at this, we've got the same answer for the denominator and the numerator on both sides. And remember, one of the important things of this formula is that we have a minus over here, so we have to multiply by a minus 1. So with this formula, we've checked and we've got the right answer. So now that we have checked this equation, let's do the next one. So this one is 3xy minus 7x squared y plus 2y squared minus 4x is equal to 19. So let's write that down. 3xy minus 7x squared y plus 2y squared minus 4x is equal to 19. And remember, since the right hand side is just a constant, this becomes 0. So 3xy, this becomes 3x dy dx plus 3y, and then this becomes minus, so minus 14xy, so minus 14xy, and then plus, minus 7x squared dy dx. So this dy dx is with this, so multiplied by dy over dx, and then we're going to have plus 4y dy dx minus 4. So let's circle the terms which do not involve dy over dx. So we have this term, and this term. So we have 3 terms. And let's just check it. 3x and the derivative of y is dy over dx plus the derivative of 3x is 3, so 3y. So this is just going to become a product rule. And over here, we're going to get another product rule. So this is going to become minus 14xy, and then minus 7x squared dy over dx plus 4y dy over dx and minus 4 is equal to 0. So this is right. Now we have to move these onto the right-hand side. So this will become 14xy. This will become minus 3y. This will become plus 4 all over, since we can factor out the dy over dx of the remaining terms and divide. So we'll get 3x plus 4y minus 7x squared. So we'll get 3x minus 7x squared plus 4y. So now we can write this over here. 14xy minus 3y plus 4 over 3x minus 7x squared plus 4y. Now let's check this with our formula. And this is 3x minus 7x squared plus 4y. The numerator says 14xy minus 3y plus 4. Okay, so let's use this formula. So minus 1 multiplied by, this becomes 3y. This becomes minus 14xy. This becomes 0, and this becomes minus 4. We can rearrange this to get, and we can multiply by minus 1 to get minus 3y plus 14xy, and then plus 4, so to get 14xy minus 3y plus 4. So our numerator is correct. Our denominator involves the partial derivative with respect to y. This becomes 3y. This becomes minus 7x squared. This becomes plus 4x. Well, 4y. That becomes 4y. And this becomes 0. So we get 3y minus 7x squared plus 4y, and that is exactly what we have on the denominator. So if we look at this, 14xy minus 3y plus 4 over 3x minus 7x squared plus 4y, this matches this, which means we are right. So now that we have solved these equations, and we used the regular method the first time we solved them, and the second time we solved them we used the partial derivative method, we can make this video to an end. If you like this video and if you like this channel, please subscribe to learn more. Thank you.